Hey guys, this is Mr. C, and in this video we're going to talk about arithmetic sequences. So my first page here is basically what an arithmetic sequence is. It's kind of like a linear equation, except you have some terms, and it starts with the first term, second, third, fourth, and so on. And you get those next terms by either adding or subtracting the same number over and over again from that first term. And so the structure of this is as follows. You have a sub n, then that n just means, refers to whatever term we're talking about. There could be a lot of them. And that equals, that's a sequence, equals the first term plus n minus 1 times d, and d is that common difference I was talking about that you're adding or subtracting every time. The reason why it's n minus 1 here is because if we need to find the value of the first term, n is 1, and so 1 minus 1 is 0. This whole part of this goes to 0, and you would get a sub 1 back for your first term. So that n minus 1 is necessary. All right, so we're going to talk about some very common examples, and I picked a few out for you. And so our first one says that Kelly's parents gave her $30 for her birthday. If Kelly continues to save $7 each week, write an arithmetic sequence a sub n to model the amount of money she will have after n weeks. So we're going to start with a sub n equals, we need the first term, the initial amount. Well, they gave her $30 for her birthday, and so she's got $30 as her first amount, then plus n minus 1, and then the common difference. And I know the word is difference, but if you're adding every time, it'll be a positive number here. And if you're subtracting every time going down, it'll be a negative number. Well, she's going to save $7 each week. And so that means I need to have a 7 right there. You can simplify this a little bit if you want to, but this is fine to leave it like this. And that is the sequence that we need for that example. So let's take a look at this one. Jen collects sand dollars at a beach and sells them at her parents' gift shop. She ended the tourist season with 50 sand dollars left and collects 4 more every day. Write an arithmetic sequence a sub n to model the number of sand dollars she will have after n days. So again, we start out with a sub n equals, that just means the sequence. Okay, so how many did she start with? It looks like she had 50 left over from the last season. So she's beginning the next season with 50 plus n minus 1. And how much is she going to go up? Well, she's going to collect 4 more every day. And so therefore, the common difference is positive, and that's 4. We say common difference because if you look at these terms here, she would start with 50. Okay, then she would add 4 more the next day, so 54. She'd add 4 more for 58. 4 more after that would be 62. So this is day 1, day 2, day 3, and day 4. If you subtract 62 minus 58, or 58 minus 54, or 54 minus 50, each time you subtract these, this term by the previous, this term by the previous, you get 4 every time, and that's why they really call it a common difference. And you always start with 1 as being the first term. Okay, this one says, a biologist estimates that there are 290 fish of a certain species in a lake. If the number of fish declines at a rate of 15 fish per month due to pollution, write an arithmetic sequence a sub n to model the number of fish in the lake after n months. So again, a sub n is equal to, and it looks like we have 290 fish in there, plus, and then we have an n minus 1, and then it says it's declining at a rate of 15 fish per month. So that means we need to have a negative 15 for our common difference right there for that one. All right, so those are some good word problems. And now we have some problems where we have to figure out which term is missing. And so here we have the first term, the second term, and the third term of the sequence, but we don't know what the middle one is, the second one. So how can we figure that out? Well, one way to do that is, and you can make this real simple, you need to find the common difference. So one thing you can do is you can take this last term here, the third term, which is 10, subtract negative 6, the first one we have, and divide that by the term numbers, 3 minus 1. So now we get 10 minus negative 6, which is positive 16. Two negatives make a positive. 3 minus 1 is 2. And so then 16 divided by 2 is 8. Okay, so what did we find when we said 8? Well, what we found is not the number that goes there. What we found was the common difference. Because this is a lot like when we talked about average rate of change in our other video. So what we're doing is we're adding 8 every time. So let's see if that works. Negative 6 plus 8 would be 2. Another 8 would be 10. And so now we know that 2 is that number that goes in between the negative 6 and the 10. And you're adding 8 each time. And that's all you had to do for that one. Now you can make that more complicated with something like this. Now you're missing 2 numbers in between. Not a problem. First term, second term, third term, fourth term. All right, so let's do the same thing we did before. We have the fourth one is negative 12 minus the first one we have is 3 over the fourth term minus the first term. And those are our n values. So what's that give us? Negative 12 minus 3 would be negative 15 over 4 minus 1 is 3. And then that gives us negative 5 if we simplify that. And that makes sense that it's negative because it's going from 3 and it's gradually going down to negative 12 here. So it's got to be going down, decreasing. Well, negative 5 should be our common difference. So let's see if that works. 3 take away 5 would be negative 2. Take away another 5 would be negative 7. And then take away another 5, negative 12. So now that we know we have that one. Okay. Here we have 3 of them missing. First term, second, third, fourth, and fifth. All right, let's see if this works here. 15 minus negative 13. And we are going up because we're going from negative 13 to 15. So it is gradually increasing over 5 minus 1. All right. So 15 take away negative 13 would really be addition, wouldn't it? So that would be 28, positive 28, over 5 take away 1 is 4, and 28 over 4 is 7. And so it looks like we're adding 7 each time. So if we add 7 to negative 13, we would get negative 6, right? Okay, if we add another 7 to negative 6, we would get 1. If we add another 7 to 1, we would get 8. And if we add another 7 to 8, we'd get 15. So it looks like negative 13, negative 6, 1, 8, 15 is the sequence that we're looking for. All right, let's take a look at this one now. Just giving you some variety here. An arithmetic sequence is shown, and here it is. For what value of n is a sub n equal to 67? So I'm trying to figure out what value of n here and here would give me 67 as my term number. So if a sub n is 67, I'm going to take that 67 and put it in over here for a sub n. 67 equals negative 5 plus n minus 1 times 3. That is a multi-step equation. Luckily, we've seen those videos. And we need to solve for n to figure out which term that would be. So first thing I want to do is probably add the 5 to both sides. Okay, so 67 plus 5 would be 72 is equal to n minus 1 times 3. So if you take 72 and you have a choice. You can either distribute that 3 here, or you can divide 72 divided by 3, right? Because you can divide both sides by 3. If you choose to do this, it's going to be a little bit easier on you. Those 3's cancel, multiplicative inverses. 72 divided by 3 is 24. Okay, since that goes away, the parentheses go away here too. There's nothing in front. Now all I have to do is add 1 to both sides. And 24 plus 1 is 25. So it turns out that the 25th term is going to be 67. I would really not want to write out every term here until I got to the 25th one to arrive at 67. I'd want to have some way of getting that answer without having to sit there and plug n values in over and over again until I got up to 67. And this right here took all of probably 20, 30 seconds. So that one's not that big of a deal. And then you're going to get ones like this, another word problem. A business is projected to lose 65 customers per week due to competition. If the business currently has 22,000 customers, after how many weeks will the company have only 15,500 customers? All right, so we got some big numbers going on here. I want to figure out when all of this is going to be 15,500. My initial amount was 22,000. Okay, plus n minus 1, because n now is representing the number of weeks, right? That's going to take to drop it all the way down from here to here, times my common difference, and I'm losing 65. So that would be a minus 65 right there. All right, so let's see what happens here. Let's go ahead and subtract 22,000 from both sides. Okay, so 15,500 minus 22,000 is going to give us negative 6,500. That's equal to all of this, and minus 1 times negative 65. All right, well, luckily, 6,500 is a multiple of negative 65. So we can divide both sides by negative 65. These guys cancel. 6,500 divided by 65 is 100, and two negatives make a positive. So 100 is equal to n minus 1. Again, everything went away, so I removed the parentheses, add 1 to both sides, and it looks like it's going to take 101 weeks for that company to get all the way down to 15,500 customers. So those are a few example problems for arithmetic sequences. You'll see those on your EOCs and on the ACT and so on. Remember to like and share and subscribe to my channel if you haven't already. And we will see you guys later. Bye.